students, now we are going to discuss the topic tachometric survey. What is tachometric survey? Tachometric survey is the branch of survey in which the horizontal distance and the vertical distance is measured without using chain or tape or any chaining process, merely with the help of formulas. Now we are going to see the next principle of spelling. Cut. कट करता येईल ना कट कर माझं PA याला सेट करेल
बरोबर लिहिलं होतं.
Hello students, today we are going to discuss on the topic tachometric survey. What is tachometric survey? Tachometric survey is the branch of surveying in which the horizontal distance and the vertical distance are measured without any chaining process or without any chain or the tape, directly by using the formulas. The principle of Stada tachometer is a Stada method. Now what is that? In a transit theodolite, if the transit theodolite has a Stada diaphragm, the diaphragm may be of various type. If the transit theodolite has a Stada diaphragm, then that theodolite can be used as a, or that theodolite is called as a tachometer. What is difference between the normal Stada and the normal diaphragm and the Stada diaphragm? In the Stada diaphragm, you will see there are three ears: upper ear, middle ear, and lower ear. When the diaphragm is Stada diaphragm, we take the upper reading on the staff, we take the middle reading on the staff, and we take the bottom reading or the lower ear reading on the staff. The middle reading on the staff is used to find the elevation difference, or you can say is used to find the reduced level RL, we say. And the top and the bottom ear readings are used to calculate the distance. The distance may be the vertical distance, or the distance may be the horizontal distance. This distance is calculated based on the formulas. That's the reason the chaining process is totally eliminated in the case of a tachometry. And this Stada diaphragm, and when we take the readings of the three, is nothing but the principle of Stada tachometry. To the next, we are going to see methods of tachometry. Methods of tachometry. Now there is a Stada method, there is a method, it is called as the Stada method. Stada method is divided into two: fixed hair method, fixed hair method, and movable hair. Another method is tangential method, which is not there for you guys in your syllabus right now. So we are going to see these methods. What is fixed hair method? Now you know that this is a diaphragm where there is the upper layer and the lower layer. The distance between the upper layer and the lower layer is fixed, cannot be changed, or we cannot change. Then that method is called as a fixed hair method. Whereas in the diagram of a Stada type, when the distance between these two can be changed as per the requirement by making the arrangement, then that method is called as movable hair method. For you guys, movable method is not there in syllabus. So we are going to focus on fixed hair method. Now how the fixed hair method works, that we are going to see in detail right now. Fixed hair method, in fixed hair method there are three cases for horizontal line of sight. What is meant by that? In this case, the case 1 of fixed hair method is the tachometer is fixed on a theodolite and the staff is kept vertical and 3-year readings are taken. In this case, this is the upper ear reading, this is the middle ear reading, this is the lower ear reading. Difference between the upper ear and the lower ear, this difference is S, that is staff intercept. The distance between the center of the station to the staff is a horizontal distance. This is a leveling staff. This is a ground. This is a tachometer. Now, in this case, you can calculate the reduced level as well as the horizontal distance. The horizontal distance which is calculated by the formula x is equal to S into F by I plus F plus C. Now in this case, what is F by I and what is F plus C? Now F plus C is called as the additive constant. F by I is called as a multiplying. The value of F by I for today's type of tachometer is given by the manufacturer. Now F plus C is additive constant. If you see the theodolite initially, the theodolite were of two types, external focusing and internal focusing. In case of external focusing, the telescope was such that whenever you want to adjust the object length of a telescope, the object length is adjusted externally. The one part of telescope moves over the other part. Now in this case, the F by I value remains the same, but since the focal length changes, as you change the distance from object glass to eyepiece because of the external focusing, the additive constant changes. So it becomes tough for each time to calculate the horizontal distance. To avoid this, they have added a lens. That lens is called as a analytical lens. In case of external focusing, when we add the analytical lens, then the value of f plus c becomes 0. Additive constant is 0 when the analytical lens is added. In case of internal focusing, which we use right now in today's generation, in case of internal focusing, manufacturer has adjusted it in such a way that the value of f plus c by default is equal to 0 without using analytical lens. The analytical lens is applicable for the external focusing theodolite or tachometer, and for the internal focusing theodolite or tachometer, the f plus v value is 0 by default. In this case, the multiplying constant will be given by the manufacturer, and S is nothing but the staff intercept, that is the upper reading of the here minus the lower reading of the year. Whatever it get, it is S. So in case of a external focusing where the analytical lens is there, or in case of a internal focusing where f plus c is 0, the formula of the horizontal distance becomes f is equal to s into f by I. Just multiplying by multiplying the staff intercept with multiplying constant, directly you will get the horizontal distance when your line of sight is parallel to the ground. There is no vertical angle. Then in that case, the horizontal distance will be calculated by the simple formula S is equal to f by I when it is analytical lens in case of external focusing, and in case of internal focusing, by default the value of additive constant is 0. So this is the case 1 where the line of sight is horizontal and is kept parallel to the ground. Now we are going to see the another case number 2. I think you are clear with first case, so we will move to the second case. We are discussing here only the fixed hair method, and in the fixed hair method we have discussed the first case. Now we are going to discuss the second case. Yeah. In the case 2, the line of sight is inclined and staff is kept vertical. Here this is the position of the staff, this is the position of a tachometer. Now from this will be the horizontal axis when the telescope is kept normal. We have inclined it, so this is the middle here. The angle made by the middle here with the horizontal axis or a line of sight when the angle was 0 is taken as theta. This is the bottom here, this is the top here. So this will be the upper here, middle here and the lower here. This particular value is known as staff intercept. From the middle here to the base of the staff, this is known as, or the value is h. And this is the horizontal distance between the staff station and the instrument station. And from the horizontal line of sight or from the height of instrument to the middle here, whatever we get, this is a vertical distance of particular station. Now the formula of horizontal distance is given as x is equal to L. So x is equal to F by I S cos square theta plus F plus C cos theta, or x is equal to F by I S cos square theta. This is for analytical lens or for internal focusing tachometer. Now the vertical distance is given by the formula V is equal to F by I S sine 2 theta by 2 plus F plus C sine theta. The formula becomes different when it is analytical lens, because in case of an analytical lens, F plus C becomes 0. The additive constant becomes 0. So this formula is for internal focusing or external focusing with analytical lens, and this formula is for without analytical lens, that is external focusing tachometer. In this case, this is the second case. This case can be also shown by another diagram which I am going to draw. The same formula is used. Now in this case, the angle is positive. This angle is towards the elevation. To show the angle towards the elevation, the sign is used as positive. The same diagram can be drawn. Now we will see the same formula can also be applicable, only the angle will change. In this case, the staff is kept at an elevated position, whereas the instrument is kept at an elevated position, whereas the staff is in lower position. Then the telescope is moved down and the angle which is taken is depression angle with respect to the horizontal or the height of the instrument. Hence that angle which is measured with theta, the value comes as negative. The rest things remains the same. This is the upper here, middle here, lower here. The difference is called as S. The height of the staff with ground to the middle here is H. This is the horizontal distance with the center point X. But in this case, now your vertical distance is from the middle here reading to the height of instrument. This will come as V. But the formula which was there, which I have written previously, the formula will remain the same. Just to show that this is the angle of depression, the sign is taken as negative. It is not applicable in the formula. Okay, now we are going to see the problems based on these two cases. We will see different types of problems, three types basically. One, there is the elevation as well as depression, only elevation and only depression. So these three types of the problems I am going to solve it for you guys in this session, which are usually asked in the university exam. So the first numerical is, I am going to write the numerical. Question is, a tachometer fitted with analytical lens was set up at station P and following observations were recorded with staff held vertical. These are the observations. I'm drawing it in a form of a table, which is usually shown in the problem. This is the instrument station. The instrument station, as we know that instrument is kept at P. Then there is a staff station. The staff station they have marked as BM, and the another staff station they have marked as Q. Then they have given vertical angle. The vertical angle first is negative, that is 12 degree 42 minutes. This indicates that it is a depression. Okay, staff is kept in a depression. And there is another angle which is a positive angle, that is 9 degree 36 minutes. This means that this is the angle of elevation. Now there are staff readings. Which are observed in the field. It is divided into 3 parts: 0.220, 1.00, 1.780, after that 0.415, 1.240, 2.065. This is the upper ear reading, this is the middle ear reading, this is the lower ear reading. The value of the lower ear reading is lower, the middle ear reading is in between, and the upper ear reading is higher. Whichever the value is higher is the upper ear reading, whichever the value is lower is the lower ear reading, and the value between these two is a middle ear reading. Now the question is, if f by I is equal to 100, find the horizontal distance from P to Q. They have also written remark over here. In the remark they have said the RL of benchmark is 200 and we have to find the RL of Q. So here they have given the analytical lengths, that means F plus C is 0. Multiplying constant, they have given F by I, they have given RL of 1 point, and we have to find the RL of another point. At the same time we have to find the horizontal distance. Now in this case, since it is minus angle and the plus angle comes into the picture, so this is the case 2 of the STADA method. Starting with, we will first draw the sketch based on the information given. we will take a ground where there is the angle of elevation as well as depression. Okay, we will mark the staff, or we will mark the theodolite at a station P in this way. Okay, now there is a benchmark which is at depression because the angle is negative. So this is the point B. We will draw the staff at B. Okay, again there is a point P, it is at elevation, so we will draw the staff over here. From instrument station to B, with respect to the height of instrument, we will draw the height of instrument with this. The height of instrument this is HI, height of instrument. Now from that, the middle here reading, this theta of B, the value is 12 degree 42 minutes. There is a top here reading and the bottom here reading. The top here reading of the benchmark or the BM point, here we will write BM point. This top here reading they have given is 1.780. The middle they have given as 1.00 and the bottom they have given is 0.220. Okay. Now this is H value, the value between the upper and the middle here, this value is S value, and from the middle here to the height of instrument, this is V. So since this is to the station BM, we are going to write S of BM, H of BM and V of BM. Now we will complete the other part of the diagram. In this case, the angle which is there is positive, so we will take it as an angle of elevation. From the height of instrument or the horizontal axis of the telescope, this particular angle is positive. It is 9 degree 36 minutes. It is a middle here reading, so I will show it dotted so you will understand more. Then the top here reading, then the bottom here reading. The value which is lower value is considered as a bottom value. So this is the bottom value is lower here value is 0.415. The middle here value is 1.240 and the top value is 2.065. Okay. From here to the middle here reading, this is V of P, the lower and the bottom here reading, this is S of P, and from the middle here reading to the base, this is H of P. So with this, whatever they have given in the problem, we have written. We have to write one thing. They have given RL of benchmark is equal to 200 and we have to find RL of P is equal to what, and they have asked us to find the distance. Sorry, this is the Q point. Sorry. This is the Q point. So this is Q of P, Q, Q. We have to find the horizontal distance between this X, Q, P. So this is what they have asked and this is what they have given. With the help of the formula, we will calculate the horizontal distance, vertical distance, and then we will find the reduced level of the point Q. Now, to calculate the horizontal distance, since it is an analytical lens, the horizontal distance is the horizontal distance XQP will be given by the formula F by I SQ cos square theta. Now here the S will be S of Q. S of Q. So value of F by I is 100. Now S of Q is 2.065 minus 0.415 cos square 9 degree 36 minutes. If we do the calculations, then the value come as 160.4 meter. So horizontal distance X of QP is 160.4 meter. So X QP is equal to 160.4 meter. In this case, we have calculated one asked parameter. Now we have to calculate the RL of Q. To calculate the RL of Q, first we have to calculate the vertical distance. Now if you say this is like a puzzle, we know this height, isn't it? Then to this RL we will add the HB, the middle here reading, then we will add the VB. This will give me the height of instrument. To this height of instrument, if I add BQ, I will reach to the middle here reading, and if I minus the middle here reading, I will reach to the base of the Q, that is nothing but RL of Q. To start with RL of Q, the height of instrument HI is given by formula RL of benchmark plus H of BM. It is not benchmark, it is BM, it's an indication, plus V of BM. We know the RL value, we know the BM value, we need to calculate the VBM value. Now in this case, the formula of vertical distance at the station BM is given by F by I S of BM sine 2 theta by 2. F plus C will not come into the picture because additive constant analytical lens is there, so additive constant becomes 0. So F by I is 100. What will be S of BM? It is 1.780 minus 0.220 into sine 2. Now what will be the theta on this side? It is 12 degree 42 minutes divided by 2. If we do this calculation, the vertical height at the station BM becomes 33.46 meter. So this value will be equal to 33.46 meter. Now this value we will put into the formula of HI. So HI is equal to 200 plus the HB, it is 1.00 plus 33.46. So the value of HI is equal to 234.46 meter. So the HI is equal to 234.46 meter. So here we have reached to the HI. Now we have calculated HI is equal to 234.46. So this value here, it is 234.46 meter. Now we have to calculate the value of VQ, vertical distance at Q. The formula which is used to calculate the vertical distance at Q is F by I staff intercept at Q sine 2 theta by 2. F by I is taken as 100, S is 2.065 minus 0.415 sine. Now in this case it is 9 degree 36 minutes. 2 into 9 degree 36 minutes divided by 2. If we calculate this, the answer is 27.13 meter. Now we know the value of VQ is equal to 27.13 meter. Once the value of VQ is known, now we will calculate the RL at Q by the formula. RL of Q is equal to height of instrument plus VQ minus HQ. It will be 234.464 plus 27.13. Middle year reading is 1.240 minus 1.240, and if I calculate this, the answer is 260.35 meters. The RL of Q will be 260.35 meter. With this, we have completed this numerical. We have found the horizontal distance and we have found the RL of Q. Whenever such type of problem comes where there is angle of elevation and the depression, you have to first draw the tachometer, draw the horizontal height of the instrument, then the staff is kept below the horizontal height of the instrument, and in this case the elevation of the ground must be above the horizontal instrument. Then it becomes easier for us to calculate the things which are asked in the problem. Now we will move to the another type of problem. In this case we have seen one angle as negative, one angle as positive. Now we will see the next numerical. And the question is a tachometer was set up at station A and following readings were obtained on a staff held vertical. The constant of instrument were 100 and 0.1. Find horizontal distance AB and horizontal distance AB and RL of B the table, observation table they have given like instrument station. We know that the instrument station is what? Instrument station given in the problem is A. Then they have given staff station. One station is noted by the abbreviation BM and the another station is noted by B. After that they have given vertical angle, both angles are depression because the sign which they have shown is negative. Then here readings, zero point 900, 1.160, 1.420, this is 1.140, this is 1.230, the next is 1.320. Remark, they have given the RL of this as 200 and we have to find the RL of B. This is the problem which they have given us. Now you will see that they have given the constant as 100. 100 is nothing but multiplying constant f by I and they have not stated anywhere internal focusing or analytical lens and they have given this value. So this value is f plus c, that is additive. So we have f by I is equal to 100 and f plus c is equal to 0.1. To start with this, first we need as usual to draw the sketch from the observations which has been taken into the field and then we will solve the problem. Now in this case both the angles are depressive, so the instrument is kept at a height, at a elevation. So we will draw the instrument over here like this. We will consider this as height of instrument. This line we are going to take it as HI. As I have stated, whichever may be your staff position, it should be below the HI when it is in depression. So we will take it below the HI. We will mark this as a station BN and we will mark this station as a B, whereas this station is A. Now the angle made by the middle here with respect to the horizontal axis of a telescope for B, they have given 2 degree 20 minutes. The angle made by the horizontal axis with respect to the middle here reading for the station BM, they have given it as a 6 degree 30 minutes. Now we will take a, this is taken and started, middle here reading. We will take a top here and we will take a bottom here reading. The top here reading will be the maximum since this is the station B. The station B reading is, top reading is 1.320. Middle reading is 1.230 and the base reading is 1.140. The difference between this is S of B. From middle here reading to this is H of B, and from middle here to the HI, this is V of B. Now we will move to the another station, that is BM. The bottom reading, middle here reading and the top reading is 1.420, middle reading is 1.160 and the bottom reading is 0.900. The difference between the top and the bottom is S of BM. This is H of BM, and from the H to the HI, this is V of BM. In the problem, they have given the RL and they have given the RL of BM. This RL of BM is equal to 200. We have to find RL of B is equal to what, and we have to find the distance, horizontal distance AB. This is how we have drawn the sketch based on the data which is taken from the field. The only difference in the previous problem and this problem, there are two differences. In that case, one angle was positive, one angle was negative. In this case, both the angles are negative, and here the additive constant they have given. So we have to use the formula of the vertical distance by using the additive constant. But to start with, we will find the horizontal distance between the point A and B. The horizontal distance between the point A and B is given by the formula x is equal to F by I S of B cos square theta plus F plus C cos theta. Now in this case, the value of F by I is 100, S is 1.320 minus 1.140 cos square theta is 2 degree 20 minutes plus the value of F plus C they have given 0.1 and cos is again 2 degree 20 minutes. If I solve this, the answer to this x value is 18.0639 meter. So the value of horizontal distance between A and B is 18.0639 meter. Now we know the RL of BM, it is 200. We have to reach to the HI. So to reach to the HI, the formula of HI is equal to RL of benchmark plus H of BM plus V of BM. In this case, We know the value of RL, we know the value of HB. Now we need to find the V of BM, and the V of BM is given by the formula F by I as sine 2 theta by 2 plus F plus C sine theta. The value of F by is 100. We know that S is 1.420 minus 0.9, 1.420 minus 0.900 sine 2 into 6 degree 30 minutes divided by 2 plus the value of F plus C they have given 0.1 sine 6 degree 30 minutes. So the value of BM when we calculate it comes as 5.958. So the value of BM here it is 5.958. We will put this value into the above formula and we will calculate the height of instrument. So HI is equal to 200 plus H is 1.160 and VBM is 5.958. 5.958. So the HI is equal to 207.02 meter. After calculation, the value is 207.02 meter. Once we know the HI, now we have to calculate the RL of B. We know the height of instrument minus VB minus HB, we will reach to the RL of B. So the formula for RL of B is RL of B is equal to height of instrument minus, because we are going down, minus V of B minus H of B. We know HI, we know HB, we need to find the VB. Same formula we are going to use which I have shown for the vertical distance. Directly now I will put the values. The formula was F by I as sine 2 theta by 2 plus F plus C sine theta. Now in this case the multiplying constant remains same, but the S changes. The S will be, this is S of B we are going to use. So it is 1.320 minus 1.140. So 1.320 minus 1.140 sine 2 into 2 degree 20 minutes divided by 2. F plus C value is 0.1 sine 2 degree 20 minutes. If I calculate this, the value of B is 0.7348. This value comes to equal to 0.7348. If we put this value, this is in meters, if we put this value in the above formula, we can calculate the RL of B. RL of B is equal to 207.02 minus 0.7348 minus HB, that is middle here reading, it is 1.230. So the RL of B is equal to 205.06 meter. We have calculated the horizontal distance, we have calculated the VBM, height of instrument, VB, and then we have reached to the RL of B. The value of RL of B is equal to 205.06 meter. Compulsory you have to write the unit for each as they have given in the problem. the figure plays important role when you solve this problem. Such type of the problem comes for 10 marks in your end semester exam. Thank you.